So now we're up to reviewing the third page. Again, we're going over some questions from a little farther back in the past, and I have some reasons for this. Not only do we have a test coming up, and we'll have to do, every test I give is cumulative in nature, but we also have a final exam coming up. And a lot of the work we do from now till the end of the year will feature a lot of review questions. We want to be 100% prepared for that final. We want to walk into the final, have you guys take the final, and say to yourself, boy, that's just like another one of Linquist's homeworks. And if that's the case, then that means you're very thoroughly prepared. In fact, it was one of the best compliments I ever got when I taught in public schools, and kids would take the Regents exams in New York State. It's a really big state test. And they would look at me and they'd go, it's just like another review sheet. So they felt very prepared, and that's my job for you here. Just got a quick little drink there. Okay, number 6. A simple random sample of 300 people is selected from the 1,650 male students in a university business course to take part in a business analysis test. The population being considered is, it's the 1650. Remember PPSS, population parameter. Parameters are some part of the population in the survey and sample. So the population's all the ones that we're talking about here, which is the 1,650 male students. For number 7, the following frequency distribution of quiz scores. How many individuals took this quiz? Well, remember, frequency means the number of people. So when you have a frequency of 8 associated with the score of 9, that means 8 people scored a 9. Underneath that, 7 people scored an 8. 7 people also scored a 7. 5 people scored a 3. 3 people scored a 5. So if I add up the total number of frequencies, that's how many people took the quiz, which in this case was 30. Okay, so next up, draw a sketch of each type of distribution. Well, positively skewed means we've got a tail out to the right. Negatively skewed, tail out to the left. Symmetrical, it's any graph that looks the same on, pretty even on both sides. A normal curve is also symmetrical, by the way. And then D is a normal curve. And we should know very well, what that looks like. Okay, a population has a mean, for number 8 there's actually 3 parts. A population has a mean of 422. If 12 points are added to every score, what's the new mean going to be? It'll be 434, because if every single score goes up by 12 points, which is what would happen, then that means that I would have a whole bunch more 12s added in and then divided by through. So this mean is going to go up by that 12 points also, because every other score went up by 12 points. Next up, for the following sets of scores, find the sum of x's. So that just means add 3, 5, 7, and 8. That's 23. Then this means the sum of the x's, because it's in the parentheses, squared. So I've got to do that 23 squared. I get 529. The sum of x squares. Now there's a big difference between B and C. And B, because in the parentheses, the first thing you do is you sum the x's, then you square it. In letter C, the first thing you do is you square each of them, and then you add them up. So 3 squared is 9, 5 squared is 25, 7 squared is 49, 8 squared is 64. I add all those guys up and I get 147. Likewise, in letter D, there's a lot different to do here. You're going to subtract 1 from each of the x's and then square it. So 3 minus 1 is 2, 2 squared is 4. 5 minus 1 is 4, 4 squared is 16. 7 minus 1 is 6, 6 squared is 36. 8 minus 1 is 7, 7 squared is 49. I add all those up and I get 105. Okay. Next up is to construct a stem and leaf plot. And this is kind of a convenient question because they did put things in order for you. Oftentimes they don't, and when you rewrite it, you have a lot of ordering to do. This one, not so much the case. So, I notice as I look at this stem and leaf plot, or these scores, that they range from a low of 6 all the way to a high of 37. And I also notice that there's scores in the 30s, the 20s, the 10s, and if you will, the single digits, which are the zeros. So my stems become 0, 1, 2, and 3 for the digits, 10s, 20s, 30s. And then my leaves are the 6 and the 9, and like 12 is 10 is the stem, 2 is the leaf. 14, 10 is the stem, 4 is the leaf. 15, 10 is the stem, 5 in the leaf. So If I do a stem of 10, I'm going to have to go 2, 2, 4, 4, 4, 5, 6, 8, 8, 8, 9, 9. And likewise for the 2s, I'm going to do very similarly. 2 with 0, 0, because it was 2020. Then there were 321, so it would be 1, 1, 1. And then for 22s, it would be 2, 2, 2, because there were 322s, and so on. So that gives me what my stem and leaf plot will look like when I'm done. I have yet to see anything in our textbook that goes beyond that, but I have seen in other sources over the years that they like what they call a key, and they will put down 3/2 equals 32, just so that you know. So people might not get confused and think, for argument's sake, as others that we have done during the year, that it equaled 3.2. So a lot of them include a key. I haven't seen it in any of the work we've done this year, but I have seen it in other sources at other times. Okay, that's page 3.